y equals the square root of function x. So we just did powers, where those powers were nice, neat, positive integers. But what about the square roots? This is good. You're going to like this one. Again, let's have a look. Square root of function x is only defined if the original function is positive. So anything below the axis just disappears. We just say bye, goes away. So here it is. There's random function. Bye. That bit goes. See ya. All right? That just doesn't exist anymore. All right. We know when we find the positive square root of a number, it's always positive. So I'm going to get a positive answer. Okay. Again, 1 becomes a key point, knowing where 1 is, because the square root of 1 is 1. But the opposite to the last one now happens. If I find the square root of a number that is bigger than 1, then it becomes smaller. So now the new graph, the square root graph, will be below the original graph. But if it's a square root of a number which is less than 1, then the square root will go above. But 1 is 1. So let's do that. Square root of 1 is 1. So plot those in. Horizontal asymptote, it's the square root of a number that is less than 1. So it gets bigger. So I've lifted it up. Vertical asymptote, still there. The derivative, if I differentiate the square root of function x, I end up with the derivative on, actually it should be 2 root function x, shouldn't it? But anyway, that doesn't matter. The 2 is probably not that important. What's important here is you'll notice again, f dash x is on the top. So original stationary points will still be stationary points at those x values. But what happens to x-intercepts? It's on the bottom of the fraction. Undefined, yeah. So it might be a vertical tangent, or it might be it just doesn't exist. Usually we'll end up with cusps and things like that. So stationary points will still be stationary points. Critical points, so those vertical tangents, where there are x-intercepts. Now, here's a little graphic which sort of gives you an idea. If you know what the original function is, obviously it makes life a lot easier. Because if you know the original function was, say, x to the power of 4, well, the square root of x to the power of 4 is x squared. So you're still going to get, at that x-intercept, a neat turning point. Okay? So it's not necessarily always going to be a vertical tangent. If you knew that was x to the power of 4, I don't get a vertical tangent at the x-intercept. I still get another turning point. X cubed, well, then the bottom would disappear. And so at that point it does become undefined because you don't have a left-hand side of the curve. X squared, what happens? Well, find the square root of x squared. It's plus or minus x, but you'll end up with it like a V shape, like the absolute value function, because you'll have a linear function coming in on either side instead of a curve. And so you get a sharp point there, undefined. X to the 5 on 3, if for some insane reason you might happen to have that. But again, you can use that idea, well, hang on, 5 on 3, underneath will disappear. But with these, you'll notice what we're starting to get, these vertical tangents. So it starts to round. The majority of them will round. So cusp, sharp points, but just keep an eye out. If you look at the original graph and you go, you know what, that root looks like a double root. So if I think it's a double root, therefore when I find the square root of it, it'll be a single root. So it's going to come in sharp. If you think it looks like x to the power of 4, then you think, oh, okay, in that case, when I find the square root of that, that's going to be a double root. Now, if you think there's any ambiguity, just explain yourself in your diagram. So you'll draw your diagram, but explain why you chose to make it a vertical tangent, or no, I've still got a turning point because I think that looks like a root to the power of 4, so therefore the square root of that. Explain yourself. It might not be the graph that they're looking for, but if it's open to interpretation and you can explain it, they're more interested in that. Okay, you obviously understand what's happening. You've interpreted it differently to what the original intent was. Let's go back to random graph. I think I'm going to get vertical tangents here because originally it cut through like y equals x. And so if I was to square root y equals x, so many times it cuts through straight, I would get x to the power of a half. Well, that's a parabola on its side. So you would have a vertical tangent at that point, because you'd have that curving like a parabola, or even a semicircle in some cases. Okay, let's put some more points in. Our stationary point stays stationary. Square root of a number bigger than 1 becomes smaller than 1. I've got my x-intercepts. Yeah, okay, it's not the world's greatest graph in the middle there, and I might have kind of exaggerated my vertical tangents, but that's what I was attempting to do. I was trying to get a vertical tangent at those points and get some sort of rounding. I got it, woo, there we go. So that's y equals the square. What if instead of saying y equals the square root, they said y squared equals function x? What difference does that make?
Well, y equals plus minus the square root.
Very good. So now it'll reflect. So there's y squared equals function x. So if they just say y equals square root, it's just positive. But if they say y squared equals function x, then you have plus or minus the square root of function x, and you'll get that reflection in the x-axis. All right. Hey, gee, play with some of those.